This is the video lesson for distance versus displacement. The learning target for this lesson is, I am learning to define and use distance and displacement when working with one-dimensional motion.
The success criteria for this lesson are, I can define distance, I can define displacement, and I can use distance and displacement when working with one-dimensional motion. All right, so what is distance exactly? So distance is how much ground an object is covered. It's a magnitude only. So we don't care about the direction that somebody is traveling when we're talking about distance. So this makes distance a scalar quantity. And distance may be a curved line. And it may even go over itself. It's not really that important. You start here, you end up here. You can take this kind of curvy path this whole way, tracing this whole path. That's the distance. Notice that we went over the path. We crossed over where we started here. We crossed over this part. It doesn't matter. Distance is the entire ground, how much ground you covered. So here we have a Google map drawing of the distance from the Texas Capitol down here up to Cedar Park High School. You'll notice that we're taking 35 up, and we get off on Mopac. So we start on 35, we get off on Mopac, we go up until we exit off on 183, it looks like. Then we go on Anderson Mill Road. So notice that we make these turns. We could, if we had to, make a U-turn, go back down, turn back around again, and then go back up Anderson Mill. All of that would still be included in the distance that we're traveling from the Capitol up to Cedar Park High. Doesn't matter that we turned around. It doesn't matter if we started at Cedar Park and went to the Capitol, or if we started at the Capitol and went to Cedar Park. None of that matters when we're talking about distance. It's just the amount of ground that we covered. So what's different between distance and displacement? So displacement is an object's overall change of position. So how far something is from where it started. So displacement includes both magnitude and direction. So displacement then is a vector quantity as opposed to distance, which is a scalar quantity. And displacement is always a straight line. So if we had our example before where we started over here at the X and we ended up at the Y and we took this weird circuitous route, the distance is the red. Displacement would be this blue line. Doesn't matter what the route actually was. All we want to know is how far we went from X to O. And we want to know the direction that we went. That's displacement. So this is an example of displacement. So this is from, it's another Google map. This is from Google Earth this time, actually. So this is, we're going from the Capitol building up to Cedar Park High School. And notice this is a straight line, no more curving lines. We're going straight from the Capitol building to Cedar Park High School. So the directionality matters. Notice that the amount of distance that we traveled is about 15 miles. The other distance, when we were talking about just the distance, when we went up 35 and transferred to Mopac, or 183 it looks like now, was about 25 miles. So distance is longer, displacement is often shorter. Displacement is always a straight line, and it is a vector. So the direction that we go in is important. So do a couple of quick examples here. So distance, if we start here and we end here, take this curvy path, the whole distance that we travel, everywhere we go is important. For displacement, on the other hand, all we want to know is the straight line path. How far is this straight line path? That's the displacement in blue. Now, it can get a little tricky with distance and displacement. Let's imagine that you're running on a track. So here's the starting line and the finishing line. So we start here and we finish here. If you ran 4 laps, so you ran a mile on the track, your distance would be 1 mile. On the other hand, in terms of displacement, if you ran 4 times around the track, because you start and stop at the same place, your displacement would be 0 miles. Start and stop at the same place. Zero displacement. Okay, everyone, go out there and keep asking questions. It's how you learn new things.